because my dum dog had to squeeze out underneath the fence and run away. I did get him back. Sometimes I wish he would just. Let me check online. This is the last unit, which is gonna have to spread over into next 6 weeks. We are starting evolution. I can't do all of major evolutionary milestones in 7 days. It's impossible. So we're going to talk about the Precambrian today. It's going to take us 4 days to do Cambrian, and then I'm not quite sure what I'm going to do specifically next week, because I literally have 2 days left before I have to shut stuff down to be able to test y'all before we start up CBAs, which is the following week. So CBAs are not next week, but they're the week after. There's 7 weeks. There's 7 weeks in this 6 weeks. This is a full week. Okay, next week is 4 days. There's no school for y'all on Friday, the 12th. No. Next week, the 12th. And then also I want to say the 15th, which is the following Monday. I think. Next Friday is a professional development day for teachers, and then the following Monday is a bad weather makeup day. So as long as we don't have like snow, you do not have a mask on, and I just lost somebody to COVID. So you guys have an extended, not this weekend, but next weekend. You guys have what, 1, 2, 3, 4 day, four day weekend. Grab my online kiddios back. Willard, Gil. You guys were supposed to have taken your test within the 24-hour period, or you were marked absent Friday. I did open it back up. I had to do a hard cutoff at midnight so I could do attendance Saturday morning, but then I opened it back up for those of you that have +1 day. But that ends this evening. Okay, so I've got Leland, Chase, Colton, Isa, Joseph, Sarah, Taylor. All right. Like I said, I got here late because my sweet, beautiful dum-dum dog got out underneath the fence. I got to fix that. So let's see, we found the right page. Alrighty. We talked about this opener before. You have a hat on, Johan. I mean, not Johan. I'm so tired right now. I swear I've been up since 11. I got that news. We have mentioned this opener before. The first type of life, like real life, was what? Bacteria. Do you know what type of bacteria specifically? Archaebacteria. Do you know what archae means? It honestly translates to old. that's what it translates to, or first, or primal. So these archaebacteria, where did they develop? The volcanic vents at the bottom of the ocean. There was no such thing as photosynthesis back then. So what did they use for food? Exactly, the stuff coming out of the vents, which was primarily sulfur. Yes, they did. They became essentially the grass at the bottom of the ocean. That bacteria was the beginning of the food chain. It's called chemosynthetic life, not photosynthetic life. That is where life started on this planet. That is where it has completely rehashed time after time. We've had monstrous mass extinctions, which we will at least get to the Permian mass extinction on Friday. Like I said, I'm not sure where I want to go next week. I have 2 days. I cannot get into all of the dinosaur time period. It's physically impossible to do all of that in 2 days. So I'm not sure what I'm doing quite yet next week. I know what I'm doing this week. So first 2 types of life were called archaea, A-R-C-H-A-E, archaebacteria. bacteria. They formed at the bottom of the ocean in sulfur vents. And so they synthesized sulfur. That was the grass. That is the grass, for that matter. They're still there. They're still there. They don't care. They've been there for, I can't tell you how many billions of years. Chomping on the sulfur, and then the other things are chomping on them, and it creates the food chain. I am so hoping that all of this has animated right, because I got here late, and yeah, it's going to be a day today. So we are specifically talking about Precambrian. This is when life started at the end of, now it's been a while since I've talked about some of these phrases, at the end of the Hadean. That was the beginning of cellular life in the form of bacteria. It's not like what you think nowadays. In fact, most of Earth's life has been bacterial in format when you're talking about the grain stream, like the time frame. Most of it has been bacterial. Before we had bacteria, the phrase that I remember when I was your age was, it was the primordial soup. That is the phrase that I remember. That it was amino acids and peptids and just proteins, things like ammonia and methane, these things that were necessary to be able to actually spark life. And we do have fossilized compounds. As messed up as it is, we didn't have the ability to actually be able to analyze them until much later. We didn't know that that's in the rocks themselves. But our oldest fossilized life, which I did not print this guy out because I just ran out of time, somewhere from 3.5 back to 3.8, once again, BYA's billion years ago. So Earth started about 4.6, give or take, a little less than that. And within 100 million years, we had the predecessors of life. They weren't necessarily fossils, like what you think of as fossils, but that's where life started. It started at the bottom of the ocean. It's still doing it right now. Our sun could go out, and that entire food chain would not care, as long as the core of the earth doesn't go dead. If that happens, then their food supply, everything else collapses. Okay, so fast forward about a billion years beyond that, and we had the mutation of photosynthesis. Once again, it's just been a while since we've talked about these. I went back and I like double, triple checked all of my numbers, and there's a little bit of wiggle room in between everything. But give or take 2.5 billion years ago, we had green algae. We had the first cyanobacteria. We had the first photosynthetic life that was breathing in the carbon dioxide from the atmosphere and was turning it into oxygen gas. And that these very ancient cyanobacteria are what allowed life to be able to move on land, because it was toxic before that. It was sulfur dioxide gas, it was methane, it was carbon monoxide, carbon dioxide. Like, we would take 2 breaths and die. That sounds fun? No, I'm gonna try. I cannot remember if there's one more. There's not. Go back. There are, I guess, if I can speak grammatically correct, a couple of major correlations between what causes extinctions and at the same time what causes the next flourishing of life. And the main thing that we're going to focus on, that you're going to see, is you've got either volcanic activity, which is a death bringer, and then you've got an ice age, which is a life bringer, which you would think that the ice age would wipe out all the life, but it doesn't. It provides you protection from the sun. The ice itself does, and it allows mutations to occur during the process of the ice age, so that when that ice age ends, that life is actually better equipped to handle that new environment. The Precambrian was primarily bacteria. The Cambrian was what brought in like the trilobites, the things that had exoskeletons. That's where we get a lot of fossils from. Yes, we have some fossils from Precambrian, but it's really, really rare because there weren't a lot of exoskeleton critters at the time. What's music or whatever it is am I hearing right now? And this is not up.
I just did a drink. I'm sorry, okay?
Technically, you shouldn't be drinking it in here. Period. Chemical fossils they have all different types of chemical signatures that are preserved in rocks. Your petrofuels, the things that created oils, so many different amino acids. I'm not about to list all of them, but your proteins. Those were the things that had to be present in order to spark life with those original archaeobacteria. Trace fossils, the first real fossils, are called stromatolites, and they look like stacks of pancakes. Exactly what they look like. They literally go up against the gravitational pull of the earth in flat sheets. And what it is this bacteria originally would have been archaeobacteria, but by the time it came to the shore, which is where the stromatolites are actually preserved, it's now photosynthetic. And then we have what you think of as a real fossil, a body fossil. Things that had hard parts. That then in came water with different minerals, replaced the voids of the bone or the skeletal tissue, whatever you want to call it, because it wasn't really bone at this point, it was an exoskeleton. And then that solidified. And then we're not going to go back over fossils again. There's no way, there's no time to be able to go back over every specific type of fossil. So stromatolites, you had a growth of bacteria, which became a foundation for their babies. And their babies literally lived on top of them and made a new layer. Then they had babies, and their babies moved on top of them and literally created a pancake type formation. And these are the oldest, what we would consider a true fossil of what are called stromatolites. This is an image of what a stromatolite looks like. It may look like a rock, but they literally are layer after layer after layer of bacteria that's being formed up from the ocean or the bay or whatever you would call this. This one happens to be from Western Australia. They are the oldest known fossilized stromatolites. And 3.5 billion years ago would be before major photosynthetic life, definitely before multicellular photosynthetic life, which is why they're proto-cyanobacteria. They would be the first types of. I said, there's no way I can fit dinosaurs in this 6 weeks. Maybe I can introduce the beginning of the Triassic, but we're not going to get into like T-Rexes and Brontosaurus and all that. No, that has to be pushed back. There's just not enough time. But that literally is the fossilized remains of the first types of life that made it into the sun specifically. We mentioned these also. Cyanobacteria completely and totally altered the chemical makeup of the atmosphere. Before photosynthesis, the air was composed of gases that were emitted from volcanoes from the bowels of the earth itself. So very, very toxic. Carbon dioxide, carbon monoxide, hydrogen sulfide gas, sulfur dioxide gas. I'm not going to put all of them back up here, but if we breathed that air, us personally as humans, we would die. It would not take much. The cyanobacteria that pushed out oxygen, which is more dense than nitrogen, but is less dense than some of the other gases, the other toxic gases that were present in the atmosphere, completely and totally changed the makeup. Bacteria also produce nitrogen gas. This is what all that, and obviously carbon dioxide still had to be there, but this is what allowed plants to start to move at least onto the shore, not inland. There's a whole different section that we're going to talk about that are specifically plant adaptations and insect adaptations because they came on land at exactly the same time. Vertebrates came quite a bit later. Oh, I animated that picture twice. I gotta fix that. Our first, what you would consider real fossils. Okay, you can see the structure left behind in the rock. They're found in chert. I do have some chert that's back there in the cabinet, but it doesn't have anything that's fossilized within it. This was the first time that we had cell division. That this was asexual reproduction. It was not in any way, shape, or form sexual reproduction. That came way, 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 way down the pipe. But you had cells that would divide and they would pinch, well, no, they would expand and then they would pinch off and then they would divide and then essentially became their children. This is an image of some of the earliest type of bacteria that was fossilized in chert. The right-hand side just shows you the drawing of what you're supposed to be able to see within the fossil of the chert on the left-hand side. Oh, it's just bacteria. But we still had a proponent for life. This bottom one, that is actually photosynthetic fossilized life. That's a Canadian North American fossil. Like we said, photosynthesis started before this. It was a matter of having the material to fossilize this particular organism. That was the problem for a long period of time. And I know we discussed that the Appalachians came in about 250 million years ago, but we still had a presence of land, at least on the northern part, more towards Canada, the shields, the original parts of the North American plates that were present. Like I said, the problem that we had was there just wasn't the plant material to track the fossils until much later. Really, those happened more towards the Carboniferous, which is, we're going to talk about them tomorrow. Sorry, coworkers are going crazy. Yeah, but I have to assume that this one is still locked. The first birth of life was caused by the very first ice age. And the ice itself protected from the sun. That was the problem. The stuff at the bottom of the ocean didn't have to have UV protection. The stuff at the shore had to. And in order to help develop that specific mutation, in this case was actually multicellularity, was caused by the ice age itself. If you had life that was towards the shore, and this first ice age, they think, was a completely frozen surface. It was like a snowball Earth to the 10th degree kind of thing. Would have wiped out the major group of these protocyanobacteria, which is why we don't have a lot of fossilized evidence of it. But the ocean is still going to restart back over. You're going to notice as we go through this, and because I'm not a paleontologist or anything like that, ice ages are completely and totally tied into major life adaptations to make the life go forward. You always have something catastrophic that happens before it. It could be asteroid impact, it could be volcanic thing. We'll talk about the Siberian traps that wipes things out. and ends up triggering an ice age, which then triggers life to go forward yet again. I do not know how much you remember of your biology, but there are two major types of primal life forms. There are prokaryotes, the first types of life, bacteria, which we used to call Monera. I don't even know if they use the term Monera anymore. You've got your archaebacteria and your eubacteria. That's the way it's been split. That did not happen when I was your age. It was just the bacterial kingdom. Eukaryotes have a true nucleus. Prokaryotes do not. They have nuclear material, but it's in a capsid. It's not actually in a nuclear coat or a nuclear membrane, might be the phrase that your biology teachers used. The very first eukaryotes were protists, things like euglena, amoeba, parameciums, volvoxes. There's so many different ones that you should have learned them in your biology class. But their DNA was held within a nuclear envelope. The RNA can leave the nuclear envelope. The DNA cannot. It's trapped. There's a huge difference between what we consider bacteria, Monera, prokaryotes, whatever you want to call them. They're not exactly the same thing. They still have DNA material. It's just not within that nuclear envelope. And honestly, this right here, which they can't see me pointing, but this right here fell within that ice age. The first ice age that we've got record of. Which I'm not going to go back over that again, but we take a look at the two major isotopes, well, three major isotopes of oxygen and how much is prevalent. Lets us know, was it really hot or was it really cold? I have some pictures of the first types of life, at least more modern. Obviously, the original ones, were fossilized in stone. But their ancestors, at least some of them, survived enough to be able to produce current offspring that are still viable. The earliest eukaryotes, honestly, to me, they look like a nerve cell, is what they look like to me. The way that they spread out, and then they have these fingers, or with a nerve, we call it dendrite. But the oldest body fossil is actually one that's preserved within the rock itself, are way younger than your first photosynthetic life. The one on the left is the Glothosporidium, and the one on the right is the Stiagia. But they look very, very similar to each other. The one on the right looks a little bit hairier to me, if you will. The filaments are a lot skinnier. You find the oldest life along the shields from the Precambrian, which is the darker part on here. This is not the first time you've seen this image. But these darker parts, they can also be pointing at the screen. These darker parts, these were the earliest land masses. Okay, everything else would have been covered with water, which is what allowed life to flourish. Now, when Pangea came together, it squished. This was post Pangea, but when the Euro-American plate and Gondwana came together, it sort of squished the areas away where those reefs now were above land, which triggered a mass extinction. We'll talk about that specific extinction later on this week. Picture on here, I think. The absolute earliest skeletal structure is actually Precambrian. It bridged the gap between the Precambrian and the Cambrian, but this particular organism started technically within the older era. We honestly, for the longest of times, thought that these exoskeletons were a Cambrian development, which was another ice age. That was snowball Earth. That was the cryogenic ice age. Things like trilobites. All the different kinds of plant, the plant organisms, the crinoids. But the oldest skeletal structure is technically Precambrian. You know what? I need to take attendance on her. I haven't even touched it. Check it real quick. Okay, Braylon Chase, Joseph Taylor, Sarah. Okay, so who am I missing? Alicia's here, Jimmy, Cameron, Kale, Erica, Hayden, Caitlin, Otis, Alexis. Happens when it's cold and dry. We had a huge influx of all different kinds of body styles, body shapes, exoskeletons. It was all marine. Things that looked like sea urchins and fronds, and we had reefs that were starting to develop. We didn't have necessarily early Cambrian, which you would think of as clams and oysters. The bivalves came a little bit later. But the Cambrian explosion, and this is where I ran out of time to start highlighting stuff that was important, saw a huge development in different structures of life. Now, they didn't all survive mass extinctions, but this was, and I'm almost positive, I've got images of the Edicaria, all the fronds and the tube worms and all the other things that were starting to develop later on in this. If it's not today, it's tomorrow. There was another ice age at the end of the Ordovician that wiped out a whole bunch of stuff. This is a mass extinction. But it also allowed for explosion of life behind it. Mm-hmm. Also, we're still trying to get them to replace the lock over here. The lock on the bathroom. Our key should open them, but they don't. They're not from the same time period. Okay. I did put the picture of this. This particular time period when the Cambrian just exploded with and I don't mean like bomb exploded, just had a massive amount, all different kinds of organisms that were developing. It was all marine. You had things that were very similar to prawns. Okay, so these guys down here. That guy, the thing that looks sort of like a I don't even know what the thing is supposed to look like. That's actually an animal that crawled along the bottom of the ocean floor. But there's a bunch of them on here that were crawling on the bottom of the ocean floor, predecessors of like sea cucumbers, other things that exist today. This time period literally split the eras. So we had the Proterozoic, Proterozoic, and then we had the Phanerozoic. So Phanerozoic meant, the Phanerozoic meant true life. Before that was primarily bacterial in nature. My coworkers are dealing with water. These are these guys. So this one right here is a fossilized version of this guy. They're the same organism. This particular organism, which I can't see me pouring on the screen, this one was sort of like the sea fronds, the plants. And this was another organism. This is a predecessor of the trilobite. Another organism that actually ran around on the bottom of the ocean floor. So we've got, it was this guy, was the first one. This was the second one, and that was the last one. And that is a very, very, very early version of that trilobite. Shelly started. Now I'm actually dumping into the Cambrian right now and out of the Precambrian. Shelled organisms are Cambrian. There's so many different types. This is not oysters and clams yet. These are the predecessors of them. The fossils that I ordered and finally came in had a bunch of these, like the Foraminifera. These things were not necessarily tiny. Now, this predator, and this was in the Cambrian, this is when predation sort of just blew out of the water. Very similar to a brine shrimp, except the brine shrimp is this big, and that thing was almost as tall as a person was. Some of them had weird sets of eyes. There was one that had 5 eyes, and I'm not sure if I put that one on here or not. I think I did. I did. All right, so that weird thing on the left, all of these were marine. Everything right now was marine. I have both the computer animated version, maybe the CGI, because they're not alive right now, and the actual fossilized version. Oh, I don't know. It's terrifying looking. The one on the right, the Cinderella, it's not spelled the same as the movie. It's very similar to a horseshoe crab. Yes, it is the predecessor of the trilobite. Trilobite, lobite, lobe. You had one here, and one down the center. That is literally what trilobite translates into, is a 3-lobe organism.
I think it's pretty funny that one called.
Yeah, it is. It's like somebody's hallucinating. It's a messed up looking predator. Do what? Well, they're not around anymore. I don't know if they were toxic. If it was like the what's the Japanese fish where you eat it and it makes your mouth fugu? I think that's what it's called. Okay, we're going out of the Precambrian into the Cambrian. This organism had 5 eyes over here on the left. The one that was shown next to the person that was almost as tall as we were, but in length. That's this guy down here on the bottom right. In the Cambrian, like I said, we had a huge influx of predation that was occurring. And the one on the top is the fossilized version. Obviously, the one on the bottom is a computer image of what it, in the maker's eyes, would have looked like. So, yep, that was the last one. Okay, now let me go back and let me pause this. And let me go into figuring out who did not take the customer. Like I said, I put a hard freeze on it at 11:59 Friday night so I could take attendance Saturday morning. Let me pause. Let me pause this real quick. I'm gonna stop recording.